Hi, everybody. So my name is Magid Kamal, as you know. So we'll speak about lean prototyping in fashion. I know it's a new subject here, so most of you specialize in IT sections, but I will best use of also IT knowledge that I have just to invite you all later on to initiate some ideas how we can implement your knowledge in my field, in fashion. So I have a practical background, so I will make it between theory and practice, and then I think later on discussion we can speak more about this. So blended prototyping, it's a research have been done, part of it in Germany and part of it in Egypt. So what we mean by blended prototyping, in fact this word blended, it comes from blended learning approach. Blended learning, it comes part offline and part online. So we'll speak about that, how we can develop this approach, new approach in prototype blended learning approach. So there's the sponsors. And I will try to we answer these three questions together. The first one, what is traditional prototyping in fashion? Because it's new for you, so I will explain just in 2 minutes. And then how could we improve the prototyping process through integrating 3D virtual reality and virtual technology. And finally, I will show you a case study. So really, what is the impact of implementing this visual prototyping in fashion supply chain? So we'll go through supply chain in garment production. What about 3D design technology, virtual prototyping, and then case study about virtual lean prototyping. All of these in 10 minutes. So I will try to, to keep the time. Supply chain management for garment productions. So I see here started from raw materials, which is make cotton, wool, to go to spinning, to make a yarn, and then weaving, knitting to make a fabric. So dyeing process and the finishing, and then come to producers. And after producer, we sell to the retailing companies or brands, big brands. So under producers, producer can produce in-house, but also can subcontract others, and can buy accessories from outside, and can get directly fabric supply. So the company could be vertical integrated, but could also use subcontractors as well. So there is always problems here between producers and the brands, that the brand need everything, need to deliver just on time, at reduce the cost, need high quality. So there are a lot of challenges that meet the producers to meet this demand from the, in fact, producer alone couldn't fulfill all these requirements. We could control all the supply chain, in fact, to be able to serve the final customers. But for today, we'll focus about producers only, garment manufacturer, which is producer, and in our case, the producer will produce in-house. It is a case study. And we'll try to select only one process, which is prototyping process. How the producer can improve or enhance, optimize the prototyping process to fulfill the requirement of the brand, the customer. So the idea now is to use 3D design technology. And this idea is started beforehand when 3D scanner had been developed. But before I go to 3D design, I would like to explain simply what is a traditional process in garments industry. So it's normally if we would like to develop products like this, cycling, sportswear, anything, so we need a measurement table. We need the design specification, anthropometric knowledge to derive rules of proportions. And in this case, there is a pattern designers who can make the pattern in 2D and then make the garment, sew the garment, and finishing the garment to export it to the brand. So after developing 3D body scanners, many companies around the world have developed these 3D scanners, so we can scan the body with 3D camera from all around to get at the end the figures from front, from the back, from the sides, and then we can export this figure later on to a screen on the computers. So we can control the dimensions of this figure later on for sizing systems, because you know in garments we have many sizes: small, medium, large, extra large, for example. So we can control whatever we like. So we get these figures or this torso on the screen, and we can take the measurements we need for the sizing table, but we can change also the dimensions as the target market needs. So there is a torso that we have got through 3D scanners. So we can draw our designs, especially for body-fitting clothing. So we can draw, for example, that's the bib short that we have talked about. So we get the comprehensive surface generations, and then model design on computers. We can select the colors, we can select the model designs, different colors, different stripes, whatever we like. And then the challenge here, how we can flatten these 3D designs to get these 2D patterns. In fact, it is headache normally in traditional process, and then Youssef, where it's a French company, in fact, have developed it. And we have done in Dresden University of Technology a project to help the company to develop this for garment industry. Because in principles, this idea was in the seating industry, in car seat industries, and they have worked it since many years. But for fashion, clothing industries, it is new, in fact, has not yet implemented. Yes, so we need to have these 2D patterns, but we need the material properties here, because we couldn't flatten it without knowing the material properties. So we're going for done some tests. There is a lot of, we call it fast fabric assurance by sample testing, to examine some properties like tensile properties, like bending properties, compression, dimensional stabilities, all the properties needed for a certain purpose. And after we get this data, we come back to the computer to feed the computer with the data, and then we get directly the pattern in 2D. But as we have seen, there is here some areas, it seems like there is more stress or it's tight on the body. So when we see these indicators, so we should do something for the pattern. We can have some additional cut. We can increase the fabric in some area just to get the pattern flattened and get the right fitting as well at the end. So we can also add colors, visualization in 3D after that. So we now have the fitting. We have the 2D patterns. We can sew it. We can have the garments at the end. But visually, we can also show it in 3D. And we can, if we find like figures, we can put it again on the mannequin and use another software just for more fitting and to assure that it's fit well as well. So softwares like Browswares, we can also use the 2D patterns again to check that our fitting is good, and then we can use another mannequin and to see it in 3D as well. So now the case study, we go to ask the companies, like we have selected 5 companies who export garment for American and the European countries, ask them, this principle could work in your companies. Can you please ask your buyers? And we have interviews, we have some questionnaires with the companies. It is most of the different companies, different sizes, as we see here. The answer was no. We couldn't use these 100% because the customer need to feel the fabrics. If we make everything in 3D and online, the buyer is not satisfied. He would like to feel the fabric, to see the quality, the processing of the fabrics. So what we can do? We have thought about this new principle, blended learning. Okay, let us examine it again. So we'll find solutions. Some of the process we can do online, and some of them we can do offline as well. So this is the process in sampling from idea generations, product development process, 2D pattern sample productions, and until the end. So we think to do this virtual at the beginning, and after further discussion, questionnaires, and feedback from the companies, we have reached a new model. Okay, these new models, as we see here, 3D scanner we use. we can, if the 3D scanner is expensive, in fact, but we can import the data from any 3D scanners and get it on the screen of the computer. And then we have 3D concepts. So we'll have software for model designs, 3D generations. And already most of the company has these 2D generation patterns. It's already there. So this 3D concept, we use it as a software and to do 3D fitting, and they get automatically 2D pattern. And later on, there is a grading for multiple sizes and 2D modeling. So, and this process, which is to cut into 2D and to sew the garments, is offline, is the physical samples. So the virtual samples is a part, the physical sample is another part. And of course, there is input here, like size measurements, and as well as material properties that we have talked about. So from these examples, so the normal case, the company do like 41 samples, physical samples. After we modified and we have put the new system, it reduced until 17 samples. So there's 59% reductions in the number of samples. It's number of samples is not only materials. It is shipping, it is a lot of cost, in fact. So it is a good result, in fact. And if we see here, the saving here is about 24 samples. The difference, 24 samples, one sample average cost is about $20. So it's about $480 per order. So if the factory, average factory have like 200 orders, it is the average factory. So we'll save like 96,000 per year. It's potential saving. And the cost of the software about 150,000. So payback period would be like 1.5 years, and have the software as well. So prototyping lead time reduced by 50%, and of course it will satisfy the customer more because of this quick response that happens. Conclusion. So lean blended prototyping is working, and we would like to do more researches to assure that no problem will face the buyers and suppliers anymore. The ideas we spoke about lean, so we have reduced the number of samples, but we can speak about agility as well, and the flexibility that will happen when we're using the software and other softwares. And you might have some input from your IT backgrounds, how we can integrate the software together to work together, this 3D and 2D, for example. And in other researches, we have applied, we have tried to use ERPs in whole supply chains, and we have tried to find the obstacles that also hinder implementing it the right way. Thank you for listening. I hope that I finished on time. Thank you.